So, we looked at some properties of logarithms last time, right? What properties did we look at? Like log base a of 1 is equal to? 0, okay. And that set of properties. Here we have 3. 3 properties. Log base a of xy. So we are multiplying two things inside a logarithm. The rule is, if we have two things inside, we can separate it into addition. Log base a of x plus log base a of y. So when we take logarithms, we can change multiplication into addition. So what do you think we change division into? So of x divided by y is equal to log base a of x minus log base a of y. That's good. Next one, exponent. What does it change exponents into? Yeah. Something to consider when we talk about mathematics. We have addition, then what is repeated addition? Multiplication. What is repeated multiplication? Exponent. When you apply a logarithm, it just moves it down one stage. So exponent, it changes from exponent into multiplication. Changes multiplication into addition. So our rule says log base a of x raised to the y is equal to y times log base a of x. So we had an exponent, now we have multiplication. And you can do a bonus property that we talked about last time. So there's the 3 main ones. Here's the 4th one, to change the base formula. Log base a of b is equal to log base c of b divided by log base c of a. It could be anything. It could be 10, it could be 15, it could be anything we want. In other words, we can use this to say this is the same as log b over log a, which would imply that we've got 10. But it doesn't have to be 10 or e or anything. It could be any base we want. And we could do log base 1 million, and it doesn't change, it doesn't still work. It's just log base 10 is usually what you use because that's what you have on your calculator. Or natural log, because that's what TI-89 is. So everybody with me, we'll look at those 4 properties. So now we're going to do some examples. Let's see. Log, actually let's do ln. ln 2401 divided by ln, divided by ln, 81. And my goal is to express this using just natural log of 3 and natural log of 7. So the goal is we want to change it from this form so that we are only using natural log of 3 and natural log of 7. Any guesses on how we do that? What's 81? Why is 81 important? Okay. Divided by 3 is 0.7. That's important. What else? It's a square number. What? Okay. Okay, so she said 3 squared is 9. 9 squared is 81. Now can you rewrite this? 3 to the 4th. So I'm going to change this to ln 0.401 over 3 to the 4th. Now, is there anything similar I can do with 0.401? 4th? Okay. So instead of 24 1, I'm going to put 7 to the 4th. Is everybody looking at where those came from? So now we can start using our rules. What does division change into? Subtraction. So I can change this into ln of 7 to the 4th minus ln of 3 to the 4th. Okay? And now we're going to do one more step. Yeah, we're going to pull the 4 out front. And note, I can put it out here, ln 7 minus ln 3. Or there's two different ways I can do it. I can either put it there or 4 ln 7 minus 4 ln 3. These two are equivalent. One has a 4 factored out, and it won't matter which one you did. Everybody with me on that? How that happens?
You put in the bottom where you put your spaceship, put parentheses, you run ln 7.
Like this? Yeah. What? This one would be considered the most simplified. Yeah. Some of the problems in the homework are going to be, give you an instruction, condense. It does not mean changing a gas into a liquid. And it's 0 more. Yeah. So 4 log x plus log y minus 3 log z plus log z. Condense it into a single expression. Okay, one thing before we start, see, if we condense it, we don't have the same base on all the parts. We have the same base. Yeah, they're all 10 for all of them. So they do have the same base. So this would be something, so if for example I had a log 2 and a log 3, like that, those two could be combined. Those two could be combined, those two could be combined with them. So, let's start. First, our base is going to stay the same. So we're going to have log. I'm putting it base because all of this is going to go into it. What do we have? X to the 4th. Times y. Means we're addition outside changes to multiplication inside. Like that? You were concerned. Okay, you were correct. This piece goes on top. So, the reason I actually wrote this out specifically to see if anybody would put it on the bottom. Okay? No, if it was like this, that would apply to all of them. But when we have this plus, I mean, we are multiplying it by, and it would actually go to the top. Now, for example, I'm going to rewrite this. I'm going to change this to a plus and put that -1 in here. And now that is 1 over z here. Do you see that? Which means that we can just multiply all of these together, and that z is on the bottom. Yeah, it would be the same answer. That's why I was showing us that this, just having the minus here, we could take that minus and put it inside immediately, and make it. No. No. It's just a way so you can visualize it. We can say this is all multiplication. It's just when we have a negative, we're moving to the denominator. So if you want, you can change the problem to all multiplication. As long as you remember that negative becomes 1 over, or you have a fraction. Now let's make it a bit more interesting. we're going to do that one. What's the base in our answer going to be? 3. So now we're going to do log base 3. X. Y is 1/4. What do you think? No, we could use the 4th root of y. Is oftentimes the way you see. And then over here, I'm going to put that out front. And look at the number square root of 2 x 4th root of y. Not really. However, typically it's nice to put the number first. And that's usually the expression with the number in the first place. Oh, it's not a number.
Oh, yeah.
Yeah. Now, everybody with me with how condensing works. And the next thing we're going to do is expand. So opposite of condensing, expand. I prefer expand problems. So m. X cubed y to the 4th square root of m over 6t squared. Okay, so what are we going to have? For 3 ln x. So basically, just go part by part in each one of them. You're going to separate out, take the exponent, put it out front. So which is easier, expand or condense? Okay, how about let's see, log base. I'm oftentimes don't put in a number here, mainly because it's a lot of writing that it adds. But I put it there mainly because oftentimes on the test, I'll have at least one of them with a number there, and people forget that number. And if you forget that number, you lose half a point. So let's see, a over b squared z to the 3rd. So expand it. Okay, everybody with me? What happened?
Would it be, would it be like plus 3 log 2 because we're multiplying this denominator?
That's another important point. No, it is not, because it is in the number. No, we could rewrite this as log base 3 of a times 1 over b squared times 1 over z cubed. Right? So these are both in the denominator, which means that we could write this one as b to the negative 2 b to negative 3, and a, or z, sorry, z to negative 3. And these two are both going to have your negative number because it's negative out front. Yeah, we could change it to this form, but it does have to be negative. If it's in the denominator, it's going to have a negative part. And that is a common mistake people make when they're doing a quiz or test, is you'll see one like that and accidentally say, oh, it's a multiplication, therefore it's plus. It's in the denominator, so we're actually still dividing by it.